Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive guide to code review from the perspective of a staff software engineer. This will be detailed, practical, and cover various aspects beyond just spotting bugs. Code review, a staff engineer's perspective. As a staff engineer, your role in code review goes beyond simple bug hunting. You're responsible for maintaining code quality standards, enforcing coding conventions, best practices, and architectural principles. Knowledge sharing, educating junior engineers, spreading awareness of best practices, and ensuring consistent understanding across the team. Risk mitigation, identifying potential performance bottlenecks, security vulnerabilities, scalability issues, and long-term maintainability concerns. Architectural alignment, ensuring new code integrates seamlessly with the existing system and aligns with the overall architectural vision. Mentorship and development, providing constructive feedback that helps other engineers grow. Strategic direction, considering the long-term impact of changes and guiding the team towards making sustainable decisions. Ownership, making sure the code that goes out is something the team can confidently maintain. Setting the stage, before the review. One context is king. Understand the purpose. Before even looking at a single line of code, read the pull request, PR, description carefully. What problem is this code solving? What are the expected inputs and outputs? What are the limitations? If the PR description is lacking, request clarification from the author. A vague description is a red flag. Understand the scope. Is this a small bug fix, a new feature, or a refactoring? The scope dramatically affects the depth of your review. A large feature needs a more thorough review than a typo correction. Understand the architecture. Where does this code fit within the system? How does it interact with other components? Having a mental model of the overall architecture is crucial for identifying potential integration issues. Understand the requirements. Has a corresponding ticket or documentation already described the changes and their requirements? Is the code achieving those goals? Example. Bad PR description, fixed bug. Good PR description, fixed a bug where the user profile page would display an incorrect error message after a failed password change. The error message was referencing an outdated configuration value. This change updates the error message and includes unit tests to prevent regression. To establish code review guidelines, if they don't exist. Work with the team to create and maintain coding standards, style guides, and architectural principles. Tools like linters, example ESLint, Flake8, and formatters, example Prettier, Black, can automate some of this. Document expected code quality metrics, example test coverage, cyclomatic complexity. Make sure all contributors are aware of the guidelines. Include the guidelines in your readme.md or contributor documentation. 3 Preliminary checks. Does the code compile/run? Obvious, but essential. Automated checks, example CI/CD, should handle this, but it's good to double check locally if possible. Are tests included? New features or bug fixes should always have tests. The scope of the tests needs to match the scope of the change. Are the tests passing? Again, CI should catch this, but confirm it. A failing test suite is a major blocker. Is the code formatted correctly? Linters and formatters should handle this automatically. Reject code that violates formatting rules. Asterisk is the code base using dependency management effectively. Are dependencies managed properly? Are unused dependencies removed? 2. The core review, deep dive. 1. Readability and style asterisk. Asterisk naming asterisk are variables, functions, and classes named clearly and consistently. Names should be descriptive and convey the purpose of the code. Avoid single-letter variables, except in very localized loops, and cryptic abbreviations. Asterisk comments asterisk are comments necessary? Good code should be mostly self-documenting. Comments should explain why something is done, not what is done, unless the what is exceptionally complex. Avoid obvious comments. Asterisk consistency asterisk does the code follow the existing style and conventions of the code base? Inconsistent code is harder to read and maintain. Asterisk with e-space and formatting asterisk is the code properly indented and formatted for readability? Consistent with e-space makes a big difference. 2. Logic and functionality asterisk. Asterisk correctness asterisk does the code actually solve the problem it's supposed to solve? Think through different scenarios and edge cases. Try to break the code. Consider boundary conditions, example empty lists, zero values, maximum values. Asterisk completeness asterisk does the code handle all necessary error conditions and edge cases? Are all possible return values accounted for? Asterisk error handling asterisk are errors handled gracefully? Are exceptions caught and logged appropriately? Avoid swallowing exceptions without logging. Consider using custom exceptions for better error reporting. Asterisk input validation asterisk is user input validated to prevent security vulnerabilities, example SQL injection, XSS, and unexpected behavior? Asterisk security asterisk are there any potential security vulnerabilities? Think about authentication, authorization, data encryption, and input sanitization. Consider using static analysis tools to automatically detect security flaws. Asterisk performance asterisk is the code efficient? Are there any potential performance bottlenecks, example inefficient algorithms, unnecessary loops, database queries? Use profiling tools to identify performance issues. Asterisk scalability asterisk will the code scale well as the application grows? Consider factors like database performance, caching, and concurrency. 3. Design and architecture asterisk. Asterisk solid principles asterisk does the code adhere to solid principles, single responsibility, open/closed, Liskov substitution, interface segregation, dependency inversion? Asterisk design patterns asterisk are design patterns used appropriately? Don't over-engineer, use patterns only when they provide a clear benefit. Asterisk coupling and cohesion asterisk is the code loosely coupled and highly cohesive? Minimize dependencies between modules. Each module should have a clear and well-defined purpose. Asterisk duplication asterisk is there any code duplication? Duplication leads to maintenance nightmares. Extract common logic into reusable functions or classes. Don't repeat yourself, dry, is a key principle. Asterisk abstraction asterisk is the code properly abstracted? Hide implementation details behind well-defined interfaces. Asterisk layering asterisk is there a clear separation of concerns between layers, example presentation, business logic, data access? Asterisk API design asterisk if the code exposes an API, is the API well designed, consistent, and easy to use? 4. Testability asterisk. Asterisk unit tests asterisk are the unit tests comprehensive and effective? Do they cover all important branches and edge cases? Are the tests easy to understand and maintain? Asterisk integration tests asterisk are there integration tests to verify that the code integrates correctly with other components? Asterisk test coverage asterisk aim for high test coverage, 80% or more is a good goal. Use code coverage tools to measure coverage. But remember, high coverage doesn't guarantee good tests. The quality of the tests is more important than the quantity. Asterisk mocking and stubbing asterisk are mocks and stubs used appropriately to isolate units of code during testing? Asterisk test-driven development, TDD. If the team uses TDD, ensure that the code was written with tests first. 5. Maintainability asterisk. Asterisk simplicity asterisk is the code as simple as possible? Avoid unnecessary complexity. Keep it simple. Stupid, KISS, is a good guiding principle. Asterisk readability asterisk is the code easy to understand and modify? Asterisk modularity asterisk is the code well modularized, making it easier to change and extend? Asterisk documentation asterisk is the code properly documented? Document complex algorithms, API endpoints, and important design decisions. Asterisk dependencies asterisk are dependencies managed effectively? Avoid unnecessary dependencies. Keep dependencies up to date. Asterisk configuration asterisk are configurable parameters externalized from the code? Use configuration files or environment variables. Asterisk logging and monitoring asterisk is the code properly instrumented for logging and monitoring? Log important events and metrics to help diagnose problems in production. Asterisk error handling asterisk are errors handled gracefully? 6. Documentation asterisk. Asterisk API documentation asterisk if this code is part of an API, make sure the documentation is up to date and accurate. Asterisk README asterisk the README should contain information about the dependencies and setup instructions if any. Asterisk inline documentation asterisk write helpful code comments. 3. Giving feedback, the art of constructive criticism. 1. Be specific asterisk avoid vague statements like this code is bad. Instead, provide specific examples and explain why the code is problematic. 2. Focus on the code, not the person asterisk frame your feedback in terms of the code, not the author. Use we instead of you to foster a sense of collaboration. 3. Be positive and encouraging asterisk start with what you like about the code. Highlight well-written sections and good design choices. This will make the author more receptive to your feedback. 4. Ask questions asterisk instead of making direct statements, ask questions to guide the author to the correct solution. This encourages them to think critically and learn from the process. 5. Explain your reasoning asterisk clearly explain why you're making a suggestion. This helps the author understand the underlying principles and make better decisions in the future. 6. Provide solutions, but don't do their job. Offer suggestions for how to fix the problems you've identified. But avoid rewriting the code for them, unless it's a very small change. The goal is to guide them towards the solution, not to do their work. 7. Be respectful and empathetic asterisk remember that everyone makes mistakes. Be kind and understanding, especially when reviewing code from junior engineers. 8. Prioritize asterisk not all comments are created equal. Focus on the critical issues first, security vulnerabilities, major performance bottlenecks, etc. Leave minor style nitpicks for last. 9. Use visual aids asterisk use screenshots, diagrams, or code snippets to illustrate your points. 10. Use the right tools asterisk make use of the code review tools. For example, in GitHub. Asterisk suggest edits directly in the code. Asterisk use LGTM, looks good to me, to let the other developer know that the code has passed your standards. Asterisk request changes if the code does not meet the quality you expect. 11. Remember the goal asterisk. The goal is to improve the code and improve the developer. 4. The iteration loop, follow-up and refinement. 1. Respond to feedback asterisk. The author should address all of your comments and questions. They should explain their reasoning for making changes, or for not making changes. 2. Iterate asterisk. The code review process is iterative. You may need to review the code multiple times before it's ready to be merged. 3. Don't be afraid to ask for help asterisk. If you're unsure about something, ask another engineer for their opinion. 4. Approve with confidence asterisk. Once you're satisfied that the code meets your standards, approve the pull request. This signals that you're confident that the code is ready to be merged. 5. Follow up asterisk. Once the code has been merged, check to make sure the changes didn't introduce any new problems. Monitor the application's performance and logs. V. Tools and techniques. 1. Linters and formatters asterisk. Use tools like ESLint, Flake8, Prettier, and Black to automate code style enforcement. 2. Static analysis tools asterisk. Use tools like SonarQube, Find Bugs, and PMD to automatically detect potential bugs and security vulnerabilities. 3. Code coverage tools asterisk. Use tools like JACoco, Cobertura, and Istanbul to measure test coverage. 4. Profiling tools asterisk. Use tools like JProfiler, Visual VM, and Perf to identify performance bottlenecks. 5. Diff tools asterisk. Use a good diff tool, example Beyond Compare, Meld, to compare different versions of the code. 6. IDE features asterisk. Use your IDE's code analysis and refactoring tools. 7. Git features asterisk. Learn how to use git blame to find out who wrote a particular line of code and why. Use git bisect to find the commit that introduced a bug. 6. Special considerations for staff engineers. Asterisk. Big picture thinking asterisk. As a staff engineer, you need to think beyond the immediate changes in the pull request. Consider the long-term impact on the system and the team. Asterisk. Mentorship asterisk. Use code reviews as an opportunity to mentor junior engineers. Explain the reasoning behind your suggestions and help them develop their skills. Asterisk. Process improvement asterisk. Identify areas where the code review process can be improved. Suggest changes to the team's coding standards, tooling, or workflow. Asterisk. Architecture enforcement asterisk. Ensure that the code adheres to the team's architectural principles. Identify and address any architectural drift. Asterisk. Knowledge sharing asterisk. Share your knowledge and experience with the team. Explain complex concepts and design patterns. Asterisk. Delegation asterisk. You don't have to review every single line of code. Delegate reviews to other engineers when appropriate. Asterisk. Stay up to date asterisk. Keep your skills sharp by reading books, attending conferences, and contributing to open source projects. 7. Example scenario, reviewing a new feature. Let's say a junior engineer has submitted a pull request for a new feature that allows users to upload profile pictures. Here's a potential review process. 1. Read the PR description asterisk. Understand the purpose of the feature, the expected inputs and outputs, and any limitations. 2. Check the tests asterisk. Make sure there are unit tests for the new functionality. Do the tests cover all important cases, example uploading a valid image, uploading an invalid image, uploading a very large image? 3. Security review asterisk. Check for potential security vulnerabilities. Is the image data properly validated and sanitized to prevent XSS attacks? Is the image stored securely? 4. Performance review asterisk. Is the image processing done efficiently? Are images resized and optimized to reduce file size? Are images cached to improve performance? 5. Error handling review asterisk. Does the code handle errors gracefully, example when the user uploads an invalid image? Are errors logged appropriately? 6. Code structure review. Is the code well organized and easy to understand? Are the classes and functions named clearly? Is the code dry? 7. API review. If the feature exposes an API, is the API well designed and easy to use? 8. Give feedback. Provide constructive feedback to the author. Be specific, positive, and encouraging. Explain your reasoning behind your suggestions. 9. Iterate. Review the changes and provide further feedback until you're satisfied that the code meets your standards. 10. Approve. Approve the pull request once you're confident that the code is ready to be merged. 8. Conclusion. Code review is a critical part of the software development process. As a staff engineer, you play a vital role in ensuring code quality, knowledge sharing, and risk mitigation. By following these guidelines, you can become a more effective code reviewer and contribute to the success of your team. Remember that code review is a collaborative effort. The goal is to improve the code and improve the developers. Good luck.